Alright guys, to follow up on the video that I didn't do any context on yesterday, have been working on some Galaxian boards, and I have a very long video that I don't even know if I'm going to do on my non-working one. But anyway, figured what I would do is come back and talk about this Fluke and something else I learned, or I was messing with actually, over the weekend. So all these Flukes, if you can see this, hopefully you can see that okay, right there, could come with different options like a RS-232 port, an async bus module, etc. So there's three different options that you could get on these, and mine basically had none of them. But there is, and I'm not going to take apart the whole Fluke, but there basically is a guy. This is where the serial port would be the COM port, and yeah, they cut this out. So in this one, all that was here was this trigger output, and basically someone, I think in Italy or Spain or something like that, had designed a USB and serial card that you can put into your Fluke 9000 or 9010, I mean, and you can use a parallel cable. Optionally, you can install that, or you can use USB, which is really cool. So, and the reason you want to do that is because there's a couple ways to dump data from the Fluke is over RS-232, or obviously you can do it over this tape drive here. But these tapes are super expensive. They're unique to Fluke. I'm not going to go over all that. So almost nobody uses that tape to store programs and scripts that you can to run. So basically, I have that installed. It actually came with this Fluke that I purchased, but I'll also link to where you can buy them. There's a few, I think, still for sale here in the US on Klov that you can get. But then you need a program to actually, run things. So what you want to do is come to quarterarcade.com, okay? And I can't remember the guy's name right now, but he's been a collector and stuff for a long time. He has a website that you can buy stuff from and stuff like that. It's definitely a super helpful guy. But he wrote, originally there was this DOS program called RKSICEXE, which allowed you to communicate from a computer over RS-232 with the Fluke. But he rewrote that, or wrote a replacement in Windows called Fluke IDE, or FIDE. And I can't remember why it's called IDE, but so you want to download this, and the other thing you're going to need is on that drive, on that card, it is a FTDI chip, which allows you to do a virtual COM port. So you need to have the driver when you plug in the USB thing. So I've already installed the driver and have the USB plugged in, but we're going to install the Fluke IDE right here with you. And I'm just holding my camera, so apologies, I guess, in advance, whatever. I don't have a kind of setup that you can really do all this stuff with. But I figured I'd run through it at least one time. Going to install it there. I'll just say just me, whatever, that's fine. Okay, it says it's installed. And let's see here. Minimize this. Now, what I'm going to do is I'm going to power up my Fluke here. And we're going to go to Device Manager. And what you want to do is you definitely come in here and make sure, do I have any COM ports? Where's my COM port at? Alright, there's ports, USB serial port, Now when it first installed, I think it came up with, was installed on a different COM port, so I had to go to advanced and basically choose one of the COM ports. The FIDE or FIDE or whatever you want to call it has to use one of the first 4 ports, so I just chose COM2, and you can leave the rest of the settings there. But 9600 8901 is fine. You can change these settings within the FIDE program as well. So set up our COM port, make sure our USB is there and it's detected, and then we want to, all right, and make this as big as we can go. I don't know if that actually helps. So what you want to do is, we can go to tools. No, I forget. What am I doing? We want to come to this little thing here, set serial port settings. Yeah, I guess we have to hit that little button right there. And I think I've set it up just like this. So they're on the card that's inside of here, there's dip switches. On the one that came with Fluke, the dip switch is on their outside, the settings for this. But mine is set up just like this per the FIDE's recommended settings. So it's 9600, odd, 1, and 7. 8901 is fine. I tested it both ways, both work. It's fine. And then you have a couple, and I added something in Midway folder called the Midway Galaxian text. And so this here is a program that somebody wrote that goes, basically, we can load this program into the Fluke and it will run a script to test the Galaxian board. And that's kind of what I wanted to show. I know I didn't script any of this, what I'm talking about, so it's kind of going to be a little bit of a hodgepodge. And the way you basically do this is you have to compile the script into a format that's readable by the Fluke, which is something that looks like this Galaxian.h, which is already a compiled file, as an example. So the cool thing about the Galaxian Midway, let me just close that out. This Galaxian Midway, the cool thing about the FIDE program is it will compile it in the, I think, 9LC or whatever the compiled format is, and send it. So you can send a pre-compiled, or you can send this script and it will compile it, and this is the programming language that you're using, so you have to use a Fluke programming language, etc. I'm not going to go into details of all that, but I'm just going to show you how it works. So what you do is you come here and you press auxiliary, and we're going to do a read, and yes, we want to read. Now it's set up to read or something over that COM port, and while that's happening, you want to press that button. It tells you the instructions of what to do. Hit OK, and you see here it says processing complete. It's receiving complete. And now that program has basically been loaded over here into the Fluke. And I just wanted to show this workflow real quick, so it's obvious to people. And you can also, basically, we can write this back to the Fluke. So we can hit aux-if right here, auxiliary if, and we can say write, and it writes the program data right back to the FIDE interface because we're connected to it. But it's still inside the Fluke right now as well. And the way you access those programs is by hitting this program. Oh, don't do that. Now I probably just erased it. Execute program 0. Okay, cool, I didn't erase it. So let me hit stop. Okay. Yeah, so in the Galaxian text program file, you'll see it. I'm not going to go through the whole thing, or maybe I will. because I'm going to rewrite some of this here as we go. But it says here includes Z80 pod, so that's basically telling the program that's compiling this is that we're compiling it for a Z80 pod. Set up pod Z80, set up your trap active force line, no, so we don't actually have to do that. You saw me always doing that manually. Trap active interrupt, no, that's by default anyway. And then it tells you address space information, RAM at 4000 to 47FF program RAM. Well, if you can see that, that's actually wrong. It's 4000 to 43FF. So let's actually change that. Okay. And it's a 2114 RAM, so and the video RAM is correct. All right. Now we haven't put in the object RAM. The object RAM is 5800. Maybe I'll add that here in a second. And then it says, program title. So it's saying program. This is the first program number. Display Galaxian test program. And then it's saying output to the auxiliary interface of the Fluke, the RS-232 interface, output Galaxian test program. So as we run it, it's going to be putting that into our messages. It's going to be outputting that into that or my serial port. I'm not sure. Yeah, it's going to be outputting it here to my serial port. And then, and I haven't really messed with it. I'm not an expert by any means, guys. I'm just doing it for just started messing with this for the first time like a day ago. I've run it maybe twice. But then it says execute pause, program menu. So it's giving you different program names and telling you to do different things, like displaying different labels. And then if somebody selects 1, go to 1. If somebody selects 2, go to 2, as an example. Hopefully that's legible through the video here, through the camera. Execute program RAM test, execute program ROM test, execute program ROM screen test, etc. And so all of these program names actually get numbers in the Fluke. So we don't actually have to memorize them because this whole script here is, doing it for us. You just have to run the very first program, which is program 0. But each one of these programs in here is a bunch of different programs. And I think there is a way for me to do a program list. I'll be right back. Yeah, there's a little cheat sheet here that I printed out. What's it called? The Fluke reference card. I wish it was I had it in a card format, but anyway, there's some auxiliary IF commands here. You can send all programs. You can do aux IF, and then equal sign will send all the program numbers. So let's do that. Aux, and then this equal sign here, and you can see what it sent to my serial port down here is the program numbers. And so there's program 0, 1, 2, 3, 4, 5, 6, 7. I think that's it. Yeah. And so this Midway Galaxian, test script basically that gets compiled and sent over to the Fluke is actually 8 different programs being referenced in there, like one for running the RAM test, one for running ROM test, one for running some sound stuff, and we're going to go through that here in a second. I thought it was interesting. And so like if you, let me hit stop, and we could actually hit execute program 1, it will actually do whatever program number 1 is, and we don't know what that is actually unless we come up here. It's whatever the second program is listed in that script language of the Fluke right there, or programming language as an example. So all right, enough about that. I think we showed sending back and forth the program. So let's go ahead and power up the board and actually run the program for real. Actually, I lied. There's one more thing I like to show, I guess. Let me hit stop. If you hit aux if and then setup, it's sending all the Fluke setup information out the RS-232 line. And so you can see Z80, enable bus request is enabled, yes, wait. So all the stuff that we typically do when we're doing this setup and we're going through more, all of this stuff. Set trap active force line no, because I already started to execute that program. It actually did that for me. I didn't have to come in here and redo it manually. So that's pretty nice. So it tells you all of that setup information, including, yeah, that's it. Okay, you can see everything that is in that setup was exported here just by hitting aux if and then setup. All right, now let's power up the board. Whoops, I lied again. So I'm looking through the test script. Hopefully it's clear. And it's telling you to ground some pins and do some other stuff, whatever. Testing RAM at 7N, RAM short 4000 to 43FF. So I don't know, in the memory map it said 4000 to 47FF, but I don't know why. Maybe I shouldn't have changed that. No, I think it's okay. I don't know. But then it says to test the video RAM, learn at 5000 to 57FF. So what we want to do is we want to change that to RAM, RAM short at 5000 to 53FF. Okay. Is there anything else we want to do? No, the ROM tests are fine. Okay, so we're going to actually recompile that script real quick and resend it. So aux read, yes, we're sure, and then we want to hit this button that's compile and send. So it's going to compile it and send it again. And it says it's compiling. And oh, actually there it says program 5 is your sound test, program 6 is pause, program 7. I think there's a couple errors in here too, like the string, it says the string is too long. So like display screen, flip black, it says warning, string too long, discarding the T. So this CONT is too long. Press continue. Interesting. Alright, but anyway, so it received it. We'll just hit stop. And now let me power on the board. Alright, what I did actually, from my last video, I wasn't able to get this to run unit under test, and it was kind of flaky with some of the memory tests, this original Z80 pod. I replaced this ribbon cable here. I had a spare, this unit under test cable, I replaced that. So we are powered up, and now we want to run our program. So we're going to hit execute 0, enter. Tells us there's a Galaxian test program. What is it we want to test? Let's test number 1. Hit enter. And it's telling us to ground pin 10 of 8L, which is actually the watchdog. I'm not going to do that, but hit continue. It says ground pin 9 of 8D, which is the read pin. I'm not going to do that either. And now it says testing program RAM at 7N 7P. It's doing a RAM short right now. It should be anyway. Now it's testing the video RAM at 3F and 3H. Okay, I was somewhat interrupted by a phone call, but anyway, tested the RAM. I'm going to restart the program in a second, but one thing I wanted to show is I haven't been able to do the run unit under test on these Galaxian boards. So I just want to show with the original Z80 pod and my replacement ribbon cable there, run, and it's booting fine and working. I can coin up and everything. So, but what we're going to do is we're going to go back to execute 0, Running the Galaxian test program. Now let's test the ROMs. I actually made some changes to RAM already on the program and recompiled it. Let's go ahead and do RAM again. It says ground pin 10 of 8L. I did go ahead and ground the watchdog because you don't need it for this RAM test. So I'll make some other changes, but you do need it for some other tests here, I think. So we're just going to hit continue. Then it says ground pin 9 of 8D, which is the CPU read line. I don't think you should be doing that. Testing program RAM. And then over here you'll see that it's printing out to my serial on the FIDE program what it's actually doing. So you have a record of what's being output or what's being run. I added that. Testing object RAM 4F. Very quick. Testing video RAM. And we could do RAM longs and RAM shorts and stuff like that in the program. But this kind of saves you from, if you had a whole bunch of Galaxian boards, you wouldn't have to like type all the stuff I was typing on my other video out every time. So let's go test the screen. Hit enter. It says ground pin 10 of 8L, that's the watchdog. And it says, did the screen flip? And it's hard to tell if the screen flipped or not, obviously. But if I press continue, you can see it did flip back to what it was before. So we press continue again. Are the stars off? Again, kind of hard to see. I think in this test program, we should write something to the screen that makes it all blank. Something I'll have to investigate because obviously there's just a bunch of garbage, but you can see there's no stars actually on. If I hit continue, now you can see there's actually stars behind there. So it's testing your stars on and your stars off of the Galaxian. Now let's test sound. Let me make sure my volume is turned up, okay. Test our sound. What's going on there? Should be working. Alright, execute. Program 0. I don't know why it didn't work. Let's go to sound. Continue. I don't hear jack. Wonder why that is. It was working a second ago. Let me figure this out. Alright, I have it working. I had to reboot the board. I don't know what happened, but press background sound 1, press continue. Background sound number 2, number 3. Then it's all of them on at the same time. Damn. All of them on, all of them off. There's our hit sound, our fire sound. And did we test ROMs? Let's test ROMs. It says ground the watchdog. We're going to test version 2. And now it's saying it's testing 7U, which is right here. M866U at 7U. And obviously it's passing. And if you look at the code, I'll just scroll down here as it's executing, if I can find it fast enough. It's testing these ROMs pretty fast. But yeah, it's basically saying ROM test, gives you the memory, the address space, the memory address space, the signature that it's expecting. Now this is weird because it's saying testing the graphics ROMs, which are these, and you cannot test those with the Fluke. So I got to remove that from the program. See, it says ROM error at 2800 2FF. We do not want to loop. And it's testing the other graphics ROM, which it'll fail. We don't want to loop that, and we're done. So anyway, run unit under test, enter. I just kind of wanted to show kind of setting up the program script, and also the fact that my board is running under test now. I don't know what the Fluke program does. Oh, maybe it's because I've disabled the watchdog. Ooh, sounds kind of weird. I don't know what what that test program's doing. It's kind of flaking out the sound circuit or something. But you can see it's working. Alright, that's it, guys, for this video. That's kind of loud. That's it for this video. I just wanted to show I'm going to mess around with this script some more, which is just kind of fun, using these Fluke scripts and using the FIDE, thanks to Quarter Arcade, I mean, for making this software program. It's pretty cool. There's a ton of different scripts out there that you can load to test different boards. Unfortunately, you don't really know how good whoever authored the script was. As no offense against the guy who did this Midway one, because it's obviously gives me a starting point, but some of the stuff is wrong in here, obviously. So, but it definitely gives you a starting point of how to start making your own test script if you wanted to, instead of manually typing in, you know, all of that crap like that. So, and the RS-232 option definitely is kind of cool as well. Alright, that's it for this video. Fluke Pod is working. Unit under test, run unit under test is working, obviously, as you can see there. I'm very confident in my Fluke at this point, being able to test these Galaxian boards, and maybe we'll come back and do some Pac-Man boards in a later video, now that I have a Z80 pod that's working very consistently. And I'm also going to probably investigate some of the parts and see if I can get the run unit under test working on the repo pod as well. But both were testing memory fine. So, all right, cheers, later.